Good morning, students. Today we are going to start our new chapter, that is motion and a straight line. And what is a motion and a straight line? That is also known as the rectilinear motion. Rectilinear मतलब अगर कोई ऑब्जेक्ट सीधा एक ही डायरेक्शन में मूव कर रहा है, then that type of motion is considered as a rectilinear motion or a motion in a straight line. Now this thing comes under the category of kinematics. So what is kinematics? It's a branch of mechanics that deals with the study of motion of object without considering the cause of motion. इसका मतलब क्या हुआ कि द ऑब्जेक्ट इज इन ए मोशन, सो वी आर गोइंग टू डिस्कस ओनली द मोशन ऑफ एन ऑब्जेक्ट. We are not going to discuss the cause of the motion, that how much force we have applied, this thing we are not going to discuss. Our main point is that how the object is in a motion, that what kind of a motion the object is performing. This thing we will discuss under the kinematics. Okay, so now comes the frame of reference and reference point. This is important to understand. Now what is frame of reference? I'll give one example. When we are inside a train and in the compartment everything seems to be a static if we are sitting inside a train, but when a person standing outside the train see the train is in a motion. So there are two frame of reference. If we'll get inside the train, then everything seems to be a static in a running train. But when a person standing outside the train, he can easily see that complete train is in a motion. So there are two frame of reference. It is as similar as that. Inside the earth, everything seems to be a static. Okay, but when we move outside the earth in a universe, then from universe the whole earth is in a motion. So there are two frame of reference. One is inside the earth and another one is in a universe. So these are the two frame of reference. Now the coordinate x, y and z of the object describe the position of the object with respect to the coordinates. So यहाँ पर we do have three coordinate, x coordinate, y coordinate and z coordinate. So these three coordinate along with the time is considered as a frame of reference. Okay, now and the point of intersection of these three coordinate is considered as a reference point. This O is considered as a reference point because whenever we are talking about the position of an object, we'll see the point with respect to the origin. It is just like a landmark when we are asking an address to anyone. So that O is a landmark, or we can say that this O is a reference point. So clear what is frame of reference and what is a reference point. So now comes the path length. Now path length we have already studied in our small classes, or in class 9th, that the actual path covered by the object is considered as a path length. Suppose if object is moving from this position to this position, and whatever the path have been taken by the object will be considered as a path length. So this will be considered as a path length. Okay, and it is also known as distance, and it is a scalar quantity because it do have only a magnitude, it do not have any direction. So path length is a distance in which whatever the path have been covered by the object will be considered as a path length or the distance, and it is a scalar quantity. And then comes the displacement. It is defined as the change in the position of an object. What is displacement? It is defined as the change in the position of object in a fixed direction, which means that it is the shortest path between the initial and the final position. Suppose this is our initial position and this is the final position. So this is the change in the position of an object, and this path, which is known as the shortest path, and it is in a single direction. So this will be considered as a displacement, and this will be considered as a distance or the path length. Distance is a scalar quantity and displacement is a vector quantity because it do have both the magnitude as well as the direction. So this is all about the path length and the displacement. Now this is an example, and how we can represent the displacement. We can represent the displacement by del x, or change in the position, that is equal to x2 minus x1. So here this is x2 final position and here it is x1 initial position. So whatever be the difference between the two position will be considered as a displacement, and the actual path covered by the object will be considered as a path length. And displacement is a vector quantity. It can be zero, it can be positive, or it can be negative. अगर positive negative की बात करें, then what is positive? If the distance, if there is some displacement or change in the position, it will be considered as a positive displacement. and if again the object will come to its initial position after covering this much displacement, this much distance, then it will be considered as a zero displacement. अगर यहाँ से start किया और दोबारा से इसी point पर आ गए, then it will be a zero displacement. And if we'll change the direction of the object, then it will be a negative displacement. So there are three types of displacement. It can be positive, it can be negative, or it can be zero. Now displacement may be equal or shorter than the path length. Displacement, इसकी condition क्या है? Displacement can be equal to or it will always be smaller than the path length. मतलब displacement distance के बराबर हो सकता है, but displacement can never be greater than the path length. So this is an important point. Displacement be zero, but path length can never be zero. Displacement zero हो सकता है if the initial position and the final position of the object is same. That means the displacement will become zero, but path length will never going to be zero in that condition. Now comes the point object. We are always considering point object. Now what is that point object? Point object, if the position of the object changes by distance much greater than its own size in a reasonable direction. Means if the object, size of the object and the distance covered by the object, there is a the point size means if the path covered by the object is very much greater than the size of the object. Suppose एक ट्रेन है, वो ट्रेन किसी एक एंड से किसी दूसरे एंड ऑफ द कंट्री जाती है, तो the size of the train is much smaller than the distance covered by the train in a country. So we can say that the train is considered as a point object. Okay, so what is point object? Point object, अगर कोई भी distance जो कवर करता है ऑब्जेक्ट वो बहुत ज़्यादा हो in comparison with the size of the object, then the object will be considered as a point size. Okay, now comes the motion. What is motion? Whenever the object changes its position, the object is said to be in a motion if it changes its position with respect to its surrounding with the passage time. Time pass हो रहा है, at the same time the object is changing its position with respect to the surrounding will be considered in a motion. Now how the motion can be represented? So motion can be represented by the position time graph or xt graph. This is also known as xt graph. Now this is on y-axis we have considered as the distance, and on x-axis we have considered time. Here also there are three graphs in which the first graph the position is not changing, the distance covered by the object is not changing with respect to the time. Time is increasing but the position is the same. So we can say that this type of graph will be considered as a consider when the object is at rest. And in second one, the distance is increasing as well as the time is also increasing. Here distance is increasing in equal rate and as well as time is increasing. So we can say that the object is in a uniform motion. Matlab object is covering equal distance in equal interval of time. So this type of motion is known as a uniform motion. But in third case, time is increasing, here the distance is not increasing. Then after that suddenly the distance increases and then after that the distance stop increasing. So this type of graph in which the distance is not changing in a proper manner with respect to the time will be considered as a non-uniform motion. मतलब ये अगर कार का मोशन देखें तो कार पहले धीरे धीरे मूव करेगी और it will be in a position of rest, then all of a sudden it will start move, again will apply a brake, then the position will not change. So this type of motion will be considered as a non-uniform motion in which the object do not cover equal distance and equal interval of time. So this is all about the motion. Now after that we'll come to the speed. What is speed? The rate of change of position of an object with time in any direction. Here we have given a point in any direction. That means we are not confined to the direction. So whenever the object is changing its position with respect to the time in any direction is called speed. This you have already studied. Now what is speed? Speed is equal to distance traveled upon time. Now we know that speed is a distance upon time, so distance is a scalar quantity, therefore speed will also be a scalar quantity. That means it do not have any direction. यहाँ पर भी हमने बोला है in any direction, that means we are not confined to the direction, so that the speed will only be a scalar quantity, that it do have only magnitude but not direction. And its SI unit is meter per second and the dimensional formula is m0l t minus 1, because the dimensional formula of distance is L and dimensional formula of time is t, so it will become L t minus 1. So this is the way of writing the dimensional formula. Now comes the average speed. What is average speed? It is a total distance traveled by the object divided by total time. यहाँ पर स्पीड में क्या था, नॉर्मल डिस्टेंस ट्रेवल्ड अपॉन नॉर्मल टाइम किया था हमने, बट व्हेन वी आर टॉकिंग अबाउट द एवरेज स्पीड, सो हियर इट विल बी टोटल डिस्टेंस ट्रेवल्ड अपॉन टोटल टाइम. दिस वी हैव ऑलरेडी स्टडीड इन आवर क्लास 9th. नाउ द न्यू थिंग इज इंस्टेंटेनियस स्पीड. नाउ व्हाट इज दैट? इंस्टेंटेनियस स्पीड क्या है? द स्पीड ऑफ एन ऑब्जेक्ट एट अ पर्टिकुलर इंस्टेंट ऑफ टाइम or at a particular point of its path is called instantaneous speed. Whenever we need to find out the speed of an object at a particular instant of time, किसी एक instant पे अगर हमें किसी object की speed पता करनी है, then we are saying that that is what known as the instantaneous speed. This we have already studied in the mathematical tools under the differentiation वाले portion में हमने यही पढ़ा है कि we have considered the instantaneous speed in which v is equal to change in change in distance upon change in time with respect to the limit, where limit del t tends to 0, मतलब लिमिट जितना हम टाइम को छोटा करेंगे उतना ही ज़्यादा सही रहेगा. सो v instantaneous speed is given by limit del t tends to 0 del x upon del t, that is equal to dx upon dt. Remember that instantaneous speed will always be given by dx by dt, मतलब differential of displacement with respect to the time. So this is all about the instantaneous speed. Now comes the velocity. Velocity is a vector quantity. Why? Because it depends on the displacement, and if the displacement is a vector quantity, then automatically velocity will also be a vector quantity. So what is velocity? It is the rate of change of position with time in a given direction. You have to remember this, that it is in a particular given direction. Okay, so velocity depends on the direction. So velocity is equal to displacement upon time. It is a vector quantity because it do have both the direction as well as the magnitude. And its SI unit is meter per second. It is as similar as that of a speed. जो speed का SI unit है वही velocity का SI unit है. Similarly जो dimension formula speed का है वही dimension formula velocity का होगा. Then comes the average velocity. What is average velocity? It is the ratio of its displacement to the total time. So the displacement is given by x2 minus x1. This we have studied in a displacement topic. So average velocity is equal to displacement, that is total displacement upon total time. So it can be given by change in displacement upon change in time. So this is the average velocity. It is given by del x upon del t. Okay, now comes the instantaneous velocity. This is also similar to that of instantaneous speed, but here we are considering displacement. Instead of distance we are considering displacement, and instantaneous velocity is given by change in displacement upon change in time. This arrow sign represent that it is a vector quantity where del t tends to 0, or this thing can be written as dx upon dt, where we can say that this is the change in displacement with respect to the time. So this is all about the instantaneous velocity. Now comes the graphical. This we have already studied in mathematical tools while explaining the differentiation and integration. तो differentiation वाले portion में हमने यही किया था कि whenever we need to find out the speed of an object or the velocity of an object at a particular instant, for example here we have taken 4.5 second. 4.5 second पे velocity कितनी होगी? So what we'll do, we'll reduce the size of the this displacement को हम छोटा छोटा करते जाएंगे. Then first of all we'll take P1 and P2, then Q1 and Q2, then T1 and T2, and we'll then find out the slope at this particular point. So whatever be the slope at this point P, that will be considered as a velocity. So the velocity at t is equal to 4.5 second is the slope of the tangent to the graph at that instant. इस instant पे whatever may be the slope at this particular point P, that will be given as the instantaneous velocity at time 4.5 second. So this is all about the instantaneous speed and instantaneous velocity. Now comes the position time graph for positive and negative velocity. Suppose if the distance is increasing upward in upward direction, that means distance is increasing, so we can say that it is a positive velocity because distance is increasing with respect to the time. Here the distance is reducing or the displacement is getting down, so here we can say that the object is losing its velocity, or it is considered as a negative velocity because displacement is reducing with respect to the time. And the third one is the zero velocity, in which the object is not moving, the object is at the position of rest. In that case there will be a zero velocity. So this is all about the graph. Now comes the one numerical. This numerical is important. It is one example given in your book. So you have to understand this numerical in a perfect manner. Okay, the position of an object moving along x-axis is given by x is equal to a plus bt square. So this is the x-axis, which is a function of time. Okay, and it is a position of an object, and we can find out the position of the object. It will change the position. It will change the time in this function. So x is equal to a plus bt square, where a is equal to 8.5 meter, b is equal to 2.5 meter per second square, and t is the time in second. What is the velocity at t is equal to 0 second and t is equal to 2 second? Here we do have two time. That means we need to find out the instantaneous velocity, because they have given us the time t is equal to 0 second and t is equal to 2 second. So we need to find out the velocity of an object at t is equal to 0 and t is equal to 2 second. Next part, what is the average velocity between t is equal to 2 second and t is equal to 4 second? 2 सेकंड से 4 सेकंड के बीच में what will be the average velocity? So I think the question is clear, in which first of all we need to find out the velocity at t is equal to 0 second and t is equal to 2 second. That means instantaneous velocity, and the value of time is given t0 and t2 second. So what we'll do, we'll just find out the velocity, and the formula of velocity is v is equal to dx by dt, मतलब differentiation of displacement with respect to the time. Okay, then we'll just substitute the value of x, v is equal to d by dt of a plus bt square. Okay, so this is our function. Now a and b are the constant term, because we are already given with the values a is equal to 8.5 and b is equal to 2.5. So these are the constant values. Then what we'll do differentiation by part. Then it will be differentiation of a plus differentiation of bt square. Now we cannot differentiate a with respect to the time, so the differentiation of constant term will be 0, and the differentiation of bt square will be considered as b, because b is a constant term, तो ये बाहर आ जाएगा, and the differentiation of t square will be written as 2t. It will, the formula used in t to the power x to the power n is equal to n x to the power n minus 1. If we need to find out the differentiation of x to the power n, so this thing can be given as n x to the power n minus 1. So by using this formula, we'll get b is equal to b into 2t, or v can be written as 2bt. Now this is the velocity, instantaneous velocity, which is equal to 2bt. Now whatever be the value of time, we'll just substitute the value of time and we'll get the instantaneous velocity. Now at t is equal to 0, so here we'll substitute the value of t is equal to 0, and the value of b is 2.5 meter per second. So we'll just substitute the two values and we'll get v is equal to 2b0, or 2 in place of b we'll write 2.50, and here we'll get v velocity at 0 will be equal to 0 meter per second at 0 time. Now similarly, velocity at t is equal to 2 second, we'll just substitute the value of b and t in this equation and we'll get 2. The value of b is 2.5 and value of t is 2, and hence we'll get v is equal to 10 meter per second. So these are the two instantaneous velocity at t is equal to 0 second and t is equal to 2 seconds. So this is our first part. Now second part, we need to find out the average velocity between t is equal to 2 second and t is equal to 4 second. Okay, so for average velocity, what we can do, average velocity is equal to x2 minus x1 upon t2 minus t1. This is the formula which we have studied. Now what we will find out the value of x2 and x1. So x1 at t is equal to 2 second. Here the function x is equal to a plus bt square. We'll just substitute the value of t. Here we'll get a plus b into t square. So it will become a plus 4b. So this will be the value of x1, a plus 4b. What we have done, we have just substituted the value of t, that is 2 second, in this equation which is given in the question. Similarly, we'll get the value of x2 if we'll substitute the value of t 4 second in this equation, and hence we'll get x2 is equal to a plus 16b. Now we do have both the value x1 and x2. And after that we need to find out the value of t2 and t1. So the value of t2 minus t1 can be written as 4 minus 2, that is equal to 2 second, because t2 is equal to 4 second and t1 is equal to 2 second. So when we'll subtract this, we'll get 2 second. Now we'll substitute the two values in this equation. x2 is a plus 16b and x1 is a plus 4b. When we'll open the bracket with this negative, then automatically this positive will become negative. So hence A and A will get cancelled, and finally we'll get 16b minus 4b, so we'll get 12b upon 2. And on solving this we'll get 6b, and average velocity will be equal to 6b, and the value of b is 2.5, and hence 6 into 2.5 can be written as 15 meter per second. So this will be the answer, and this is the way how we have to solve the numerical. Okay, thank you.